All right, in this part of the video, we're going to be looking at the blue part of your rainbow review. Blue part is all about solving systems of equations and systems of inequalities. For number 1, we're asked to solve this by graphing. Remember, graphing is our least preferred method of the 3 methods that we learned, only because it requires us to have to graph, and we don't always have graphs readily available to us. And also, it's not always going to be nice little integers. And so sometimes it's going to be decimals and numbers that are going to be harder to find on a graph. But this was meant to be easy to find on a graph. We just want to make sure you understand the concept of how to find the solution by graphing. So for this first one, I'll do this one in red. So let's start, since this is in standard form, let's start by finding the x and y intercepts. So remember, to find the x-intercept, what we're going to do is we're going to cover up the y value and solve for x. So we get x equals -2. So the x-intercept's at -2. To find the y-intercept, we're going to cover up the x now and solve for y. And we get y is -2. So this one is just going to be this line here. And now for the second one, we're going to do the exact same thing. So we're going to start by, I'll do this one in green. So start by finding the x-intercept. So I'm going to cover up the y. So if I solve for x, 4 divided by 4 is 1. So the x-intercept would be 1. To find the y-intercept, I'm going to cover up the x and solve for y. So we get y equals 4. Now, I want to make sure my graph is accurate, so I look at this and I can see that my slope, I'm going down 4 over 1. So if I want to come up with another point, I'm going to go down 4 to the right one again. And sure enough, I can find where they intersect at then. So my solution, like we said, is that intersection point. So the solution for this would be the coordinate 2, -4. Now for this next set, for 2 and 3, we're going to solve this by using substitution. So remember, with substitution, we're going to start by getting one of the variables by itself. So we're going to isolate one of the variables. So I look at this first set of equations, and I see that it'd be easiest to solve for x here. So I'm going to do that by subtracting y from both sides. And I'm just going to write it like this. We'd have -3y and a +7. Now what that means is that this, what we just found x to be, this -3y plus 7, we're going to substitute that in for x in the other equation. So we would have -7 times -3y plus 7 plus 6y equals 5. Now when I distribute the -7 through, I'm going to have positive 21y minus 49 plus 6y equals 5. Now we're going to combine like terms next. So 21 plus 6y would be 27y, and I'm just going to go ahead and add 49 to both sides, and I would get 54. So now we have our y. If I divide both sides by 27, I get y equals 2. But remember, the reason why we did the previous problem is we want to make sure that we don't just say, we did all this work, we're done. We still have another step. We have to find out what x is. So the nice thing is I can use what we just found y to be and put it into either equation. I can decide which one I think would be easiest. I think it might be easiest to put y in for the second equation. So we would have x plus 3 times y, which is 2, equals 7. Now 3 times 2 is 6. If I subtract that from both sides, I get x equals 1. So my answer for this is the coordinate where x is 1, y is 2. Now the nice thing about these, remember, you can always check your work, make sure you get the same answer, the true statement basically for both equations when you put 1 in for x and 2 in for y. So let's try it in that first one. If I put 1 in for x, -7 times 1 is -7. If I put 2 in for y, 6 times 2 is 12. And -7 plus 12, sure enough, is 5. If I put 1 in for x in the second equation, and if I put 2 in for y in the second equation, I'd have 3 times 2, which is 6, so 1 plus 6, sure enough, is 7. So that's how you can check your answer. You don't have to do that all the time, but it is a good idea to be in a good habit of that. All right, let's look at the next one. So next one, I look at these and I see that it looks like this x is going to be the easiest to solve for, so I'm going to add 3y to both sides this time. So we'd have a positive 3y minus 5. So I'm going to substitute that in for x in the other equation. So I'm going to put that down here. So we would have -2 times what we're substituting in for x, 3y minus 5, plus 6y equals 0. When I distribute the -2 through, I get -6y plus 10 plus 6y equals 0. And -6y plus 6y is 0, so we get the statement 10 equals 0. Well, that is a false statement. 10 doesn't equal 0. So since the variable is completely cancel each other out. It means that we have a false statement left over here. It means that there's no solution. Okay, so this one has no solution. All right, let's look at the next set. The next set, we're going to solve these by using elimination. Now, sometimes we can't just add these together. So if I try to add these together, I'm not going to eliminate a variable. So if that's the case, I need to start by multiplying one of the equations by a number to get rid of one of the variables. Let's say if I look at this and be like, oh, I want to get rid of the x's. Well, this is a negative 3x. Remember, in order for those to be canceling out, I need those to be the same coefficient with opposite signs. So I need that to be a positive 9. So to make negative 3 into a positive 9, I'm going to multiply everything by negative 3. So that would be a positive 9x minus 21y equals a positive 18. And then the other equation, we don't have to do anything to that right now. So we would have negative 9x plus 21y equals negative 18. Oh, watch what happens. When we add these together, the 9x minus 9x, not only does that eliminate to get 0, but negative 21y plus 21y is also 0. So the left side is 0, and 18 minus 18 is also 0. So the fact that everything eliminated, including the numbers there, that means that this is a situation where we have infinite solutions. So that would be your answer. So any solutions on those lines would work. So if you were to graph these two equations, they would end up being the exact same line. They lay on top of each other. All right, let's look at the next one. So the next one, again, we're using elimination here. And I notice if I were to add these together, I'd get 15x and 12y. That does not eliminate a variable. So I'm going to eliminate the x's this time, again, by multiplying by negative 2. So the first equation is going to stay the same. I'd have 10x plus 5y equals 0. The second equation, though, when we multiply by negative 2, we'd get negative 10x minus 14y equals negative 54. Now I add these together. Now 10x minus 10x is 0. That's my whole point of doing this. And then 5 minus 14 is negative 9. So we'd have negative 9y equals negative 54. If I divide by negative 9, I get y equals 6. Now that's the y value is 6. So now I'm going to plug that in, put it into either equation. Looks like I'll just go ahead and do it in the first one. So we'll have 10x, use a different color here. We'll have 10x plus 5 times 6, which is 30, equals 0. So if this is 30, if I subtract it from both sides, I'd get 10x equals negative 30. Divide by 10, I get x equals negative 3. So our answer here would be the coordinate negative 3, y is 6. Make sure you put those in the right order. X first, y second. So negative 3, 6. And you could check that again. If I put in the first problem 10 times negative 3 is negative 30. 5 times 6 is positive 30. Negative 30 plus 30 is 0. If I put it in the second equation here, 5 times negative 3 is negative 15. If I take 7 times 6, I get 42. And negative 15 plus 42, sure enough, is 27. So that's how we can confirm that that is the correct answer. All right, let's go on to the next page now. We'll be looking at some inequalities. So this one says graph the following system of inequalities. So let's go ahead and do that. I'm going to use 4 different colors here. We'll use red for this first one, green, blue, and purple. I'll just go ahead and start with the let's start with the horizontal and vertical lines. There's really no order you have to do these in, but sometimes I like to do this, the vertical and horizontal lines first. So y is less than or equal to 2 means that's going to be a solid line. And it's y is less than 2, so it's going to be everything below there. And x is greater than or equal to negative 3, so that would be a vertical line going through where x is negative 3, and it's greater than, so it's going to be everything to the right. So right now what that's doing is that's saying that the region that my answers could be located at would be this region here. So right now this represents the region below the purple line and to the right of the blue line. Okay, so now we still have 2 other inequalities to graph here. So what that's going to do is that's going to further section this off to help us see which part of this yellow region would be our solutions. So let's just go to the top now, start with the x minus y is less than or equal to 2. And also 2, by the way, notice these were solid lines. So always make sure to check, make sure that your lines are being correct, whether solid or dashed. All right, so the next line, the red line that I'm going to do is going to be a solid line. And I'm going to start by finding the x-intercepts. So the x-intercept here would be 2. And the y-intercept, Since I have negative y is 2, I would want to change that to be a positive y, so then that would be a negative 2. So my y-intercept would be at negative 2. And again, this is going to be another solid line that we're going to connect. All right, now we're going to use a test point. If I put 0 in there for x and 0 in there for y, I get the statement 0 is less than or equal to 2. And that is a true statement. 0 is less than 2. So right now, my feasible region would be this region here, this little triangle. Okay, because that would be everything that's above that line that also intersects the previous yellow section. So I'm just going to focus on just that. All right, so now lastly, in green here, we're going to have x plus 3y is less than 6. So I notice that this is going to be a dashed line. Okay, so I'm going to go to graph this, make sure you use a dashed line. So to find the x-intercept, I'm going to cover up the y. So we would get x is 6. So my x-intercept's here at 6. And to find the y-intercept, I'm going to cover up the x. So I get y is 2. If I take 6 divided by 3, I get y is 2. So I can see there that my slope is going to go, I'm going down 1 over 3, down 1 over 3. So we can come up with some more points there. And we're going to connect these with the dashed line. So what that dashed line means is that my graph is either going to be this little triangle here, or it's going to be this shape down here. And so we got to use a test point. Again, we're going to use a point that's not on the line at all. So if I use 0 for x and 0 for y, I get the statement 0 is less than 6. Is that a true statement? Yes, 0 is less than 6. So that means that my shaded region is going to be, there we go, this black or gray area here, that's going to be my region that meets all 4 of those criteria or those constraints for the different inequalities. So that would be my solution region. All right, so let's apply this same concept to a story problem. Here it says it takes Leo 10 hours to make a table and 16 hours to make a chair. Leo works 40 hours a week. In 8 weeks, or 320 work hours, Leo wants to make at least 8 tables and 6 chairs to display to his new shop. All right, so we have a few things going on here. So first off, we're going to have a time constraint. What does that mean? Well, if we look at Leo, it takes him 10 hours to make a table and 16 hours to make a chair. Now, he does work 40 hours a week, but we're looking at 8 weeks, so 320 work hours is what we're looking at that he has available. And then he wants to make at least, actually use a different color. He wants to make at least 8 tables and at least 6 chairs is how you can read that. So we actually have 3 separate inequalities here. So the first one, if we use x to represent the number of tables and y to represent the number of chairs, it would be 10x plus 16y. And he has 320 work hours available. So now he can't work more than that. It's going to be less than or equal to 320 hours. And then we have our table constraint. So he wants to make at least 8 tables. So x has got to be greater than or equal to 8. He wants to make at least 6 chairs. So y has to be greater than or equal to 6. So let's go ahead and graph these. Let's just start with our horizontal and vertical lines here. So let's start with the y is greater than or equal to 6. So 6 would be right here, counting by 2's. So everything above that line would be a solution. And where x is 8 would be right here. So right now, my feasible region would be anything in this large area here. Now, clearly, that's not going to be the case, okay, because we still have that other inequality. But all I'm getting at is that right now, we know that our answers are going to be somewhere over here. All right, so let's go ahead and do this other inequality. So the other inequality, if we have 10x plus 16y is less than or equal to 320, well, let's find the x and y intercept. So to find the x-intercept, I'm going to cover up the y. All right, so if I cover up the y, 320 divided by 10 is 32. So we're going to have an x-intercept of 32. Now to find the y-intercept, I'm going to cover up the x. 320 divided by 16, well, that's 20. And so now to connect these, if you have a straight edge, you can connect them to make sure you're more accurate, but I don't have a straight edge, so I just want to make sure that I come up with some other points to make sure I'm a little bit more accurate. So I'm going to use the slope. So to get from this point to the 32, I know that I'm going to go down 20 units and over 32 units. So if I reduce that, I know that 4 goes into 20 and 32, so this will reduce to negative 5/8. So if I go down 8, so 1, 2, 3, 4, or I'm sorry, down 5. 1, 2, 3, 4, 5 over 8. 1, 2, 3, 4, 5, 6, 7, 8. And sure enough, 1, 2, 3, 4, 5 over 8 brings me down here. All right, so now I can connect those. And now any solution, well, actually first we've got to find our region here. So if I were to use a test point of 0, 0, I'd get the statement 0 is less than or equal to 320, which is a true statement. So anything in this, so 0, 0 is down here, so we would shade in on that side of the line. Okay, so if we shade this side of the line, you're going to notice that that side, that triangle is going to turn green. That means that's where a feasible region would be. So anything inside of, anything inside of this region would be a solution. So for example, you could even have 12 tables and 10 chairs would be a solution. You could have 10 tables and 6 chairs, and that would have worked. So anything that would be on those lines or in that triangle would meet all of those criteria. So that is how you would answer that question. So hopefully that answers the questions you had from that this last part of your Rainbow Review.